You just typed a question into a chatbot, and Python touched almost every step between your keyboard and its answer. Most people think Python is what makes an AI like this one smart. That's backwards. Python barely does the thinking at all. So what does it do? Let's follow your message and find out. Say you type, "What's the capital of Peru?" and hit send. Python catches that sentence first, and its very first job is to break it apart. It splits your sentence into small chunks called tokens. Here, 6 of them. For now, think of a token as a word. Hold on to that. Near the end, I'll show you why that's wrong. Quick guess before I prove it. Is Python fast or painfully slow? Here's the honest answer. Raw Python, line by line, is slow. Painfully slow. Look at the timing. The handwritten loop crawls next to the built-in version. So why does everyone say Python powers AI if it's this slow? Because Python was never meant to do the heavy lifting itself. It calls out to code written in faster languages, waits, and hands you back the result. That built-in sum you just saw beat the loop for exactly that reason. It runs compiled code underneath. There's one library almost every AI system leans on. I'm not naming it today. If you already know it, put it in the comments. You'll be right, and I want to see who gets there first. I'm also simplifying how those tokens get chosen. If you've built a tokenizer, tell me what surprised you. Because here's the real mystery. Python hands the pieces off and waits. So what happens in that gap? Here's the twist. Python isn't the one doing the actual thinking. It packages your numbers and hands them straight to compiled C++ code. Why hand it off? Because raw Python chokes on billions of calculations a second. Inside the GPU, thousands of tiny cores multiply numbers in the exact same instant. Python never touches that math. It just says go, then waits patiently. So, what are all those multiplications actually computing? Each number is a weight, a value tuned during training on billions of sentences. Not facts sitting in a database, patterns baked directly into numbers. Multiply your question against those patterns, and something strange falls out. Think of it like a massive vote. Every possible next word gets a score. Not an answer, just a giant list of scores, one per possible word. A pile of scores isn't a sentence. Someone still has to choose. That someone is Python again, back in control, staring at raw scores. It turns those scores into probabilities. 80% chance the next word is. Not certainty, a bet dressed up as an answer. Python rolls that weighted dice and picks one single word, just one. Ask it twice, and it might pick a different word both times. That's normal. Then the entire process starts over, from scratch, just to pick the next word. Every single word you read got generated this way, one exhausting loop at a time. That's why longer answers take longer. It's not thinking harder, it's looping more. And because each word is a guess, guesses can drift away from the truth. That drift has a name: hallucination. Confident wording, no guarantee it's correct. Python didn't lie on purpose. It just sampled a low probability word and moved on. One token down. Now Python has to do this again and again and again. Eventually, the loop stops. The model predicts an invisible end token. Now, Python has a list of numbers again, not words, numbers. So it runs the whole pipeline backwards, decoding IDs into readable letters. Then, it wraps that text in JSON and streams it back over the network. That's deliberate. Waiting for the full answer would feel painfully slow to a human. Your browser catches each piece and paints it on screen, word by word. That typing effect isn't decoration. It's literally the loop finishing in real time. So trace it back. Keyboard, Python, tokens, GPU math, probabilities, Python again, screen. Python never does the thinking. It never runs the billion-number multiplication itself. What it does is hold every single handoff together, from your keystroke to the reply. Not the brain of AI, the nervous system connecting every other part. Next time you send a message, you'll know exactly whose hands it passed through. Every handoff we traced relies on one fragile assumption. Both sides speak the same version. Update PyTorch. Don't update the CUDA driver. Watch everything break. That's not a bug hiding in your code. It's a mismatch between two separate worlds. So, production teams pin every version, Python, CUDA, drivers, down to the exact number. Data scientists call this dependency hell, and it has its own memes, its own forums, its own therapy threads. One tiny library update, and the same code that worked yesterday throws a wall of red text. This is the real cost of Python being glue. It inherits every crack in what it glues together. That's why serious ML teams containerize everything. One frozen environment, so nobody's laptop disagrees with the server. So, is Python the bottleneck, or just the messenger carrying someone else's problem? Neither. It's the one piece you can actually read when everything else fails. Zoom out from one chat message to the entire AI industry, and the pattern repeats everywhere. Data scientists clean data in pandas, Python. Researchers write training loops in PyTorch, also Python. But the pandas data frame is really C under the hood, and PyTorch's loop just dispatches to CUDA kernels. Even the chatbot's backend, the server routing your message, is usually a Python web framework underneath. Python didn't stay a tool. It became the interface. That's why job listings say Python required for roles that barely touch a for loop. Because the real skill isn't syntax, it's knowing which library to call and when. Skip Python, and you're not avoiding complexity. You're rewriting NumPy from scratch. So Python's job was never speed. It was being the language everyone agrees to read. Which is why chatbots, fraud models, and self-driving stacks all start in the same language. So why, after nearly 15 years of faster alternative languages, is Python still sitting at the center? Rust is faster. C++ is faster. Julia was literally built to beat Python at this. None of them replaced it, because speed was never the real bottleneck. People were. A researcher testing an idea in 10 lines of Python ships before the C++ version compiles. Funny thing, every framework that claims to beat Python quietly builds a Python interface anyway. So, the fastest language in AI isn't the fastest language. It's the one nobody has to relearn. Even Mojo, a language literally designed to replace Python for AI, kept Python's exact syntax on purpose. Back to that message you typed. Python never did the thinking, it did a connecting. Tokenizer, API call, model weights, serving layer. Every scene we traced needed that same connective tissue. Next time, what it actually looks like to write that glue code yourself. So what does writing the glue yourself actually look like in real code? Import a library, send your prompt as plain text, and read back whatever comes out. Under the hood, that library is just a wrapper around a single web request. That request carries your prompt as JSON and gets JSON back with the model's reply. 4 lines, start to finish. That's genuinely the entire bridge on the Python side. No neural math on this side at all. That's entirely the GPU's job. So why does everyone still call Python slow if it barely does the heavy lifting? Because it isn't computing anything. It just calls out, waits, and hands back the answer. Cut the internet connection though, and those 4 lines fail instantly. No model, no reply. Python never touches a single wait in that whole exchange. It just knows who to call. Because the glue is exactly where you decide what that intelligence is allowed to do. Swap that glue, and the exact same model becomes a chatbot, a translator, or a bug hunter. Change roughly 10 lines of Python, and that same chatbot starts reviewing code instead of just chatting. It's the same trick everywhere. Customer support bots, coding assistants, research tools, all one model underneath. No new model was trained. No retraining happened at all. Just different glue pointed elsewhere. That flexibility, honestly, is the entire game. Ever had it answer with total confidence and be completely, embarrassingly wrong? Tell me exactly what it said. Screenshot, quote, whatever you've got. I read every single reply. So, tell me, what's the dumbest thing you've ever seen an AI confidently get completely wrong? Python isn't the intelligence in artificial intelligence. It's the bridge that lets the intelligence reach the rest of the world. And now, it reaches you too.